some other examples. Maybe I'll not have the time to go through them, but then there are some examples here which are like, if you want to run, okay, I can talk about this. By the way, when I'm running on Snowy, I am getting some error on both my environments. I'm not sure if it's just me or someone else is also getting the same stuff. So let me know if someone is using Snowy. Okay, so in some miscellaneous examples, you'll find common way of running um, a deep learning code with multiple parameters, like scikit-learn gives grid search, CV, and things like that. Unfortunately, people run it this way. It's a popular way to run it. It's not bad, in which you just, okay, module load everything. You call your file, which accepts parameters, and you just keep calling that file with different parameters like this. And you keep saving the output like this. And this is also a way to run, if you know there you don't have a lot of parameters, maybe you just want to change learning rate to a couple of times, or you want to change some alpha, beta, some algorithm, or something about the optimizer. You can maybe run your same Python code a couple of times, but with different parameters. Um, this is one way of running it on the same node. In case you wanna run on a node with multiple GPUs, I have not given that example here, but you can use something like uh, device CUDA device available. CUDA device available. Um, flag, or is it called no environment variable? And yeah, this particular environment variable, CUDA visible devices. So for example, if you have two GPUs on the same node and you want to deploy a model on one GPU and another model on another GPU, maybe the same model on two different GPUs at the same time, but with different data sets, different batches, you can run like this. You can say CUDA visible device equals 0 and run your Python script after that. So CUDA visible device equals 0, srun Python, or if it's like a container or something, Python call your script. Okay. So your script will look at, okay, the environment variable set is CUDA visible device 0. That means use one GPU. Right after that line, you can write CUDA visible device equals 1, run that Python, python.py again. Now your Python script will look at another GPU because the environment variable set at CUDA visible device 1. So now your same script is looking at two different GPUs at the same time. This is also a way to work if you have multiple GPUs at the same node. And then there is this example where you run scikit-learn and TensorFlow together. You can also try this just to emphasize that using scikit-learn with other libraries like TensorFlow, PyTorch is quite common. So this is an example. Try running this. And this is batch script, so I've given how to run this here. Yep. And finally, a simple exercise to talk about using uh, just doing it once again, but let's say in an interactive node, in an interactive GPU node this time. We are not doing this because getting a GPU node interactively it takes time. But this is a simple, again, PyTorch script, already setting CUDA 0, which means there's only one GPU. Someone was also asking if how does LLM how do we train LLM with multiple GPUs at the same time? Well, PyTorch is good enough to understand that. If you have, okay, so if you like this one, this way you are telling it, device, use this device, such as this GPU, all right? But you can again run some parts of your models and change the device. So device equal CUDA colon 1. And this time it will use another model, another GPU. Well, this is also a lame way of changing the GPU again and again. By default, I think PyTorch runs it only on one GPU, unless you tell it to. If you want to know how to do it, distributed PyTorch, you can gladly read some of these articles. They tell how to run PyTorch models in a distributed fashion, both in a way where you have one node with multiple GPUs or multiple nodes with multiple GPUs. The first one is easier to do. I think it's just a matter of changing that flag again and again. But then that distributed PyTorch, and same with distributed distributed oh I think I know. Yeah, training multi GPU for TensorFlows, something similar. It also uses, I think, one GPU at the if you're not specifying it, but if you have multiple, it talks about how to do a single host multiple device synchronous training. I think, okay, so there's like a mirrored strategy. There's a variable called mirrored variable, which is like saying, I have a variable which should mirror the variable in another model sitting in another GPU device, so that when I change some characteristics of this variable, it should also change characteristics of that variable in another model, another device. What can this variable be? Well, weights and biases. You want to change the weights, right? And you want to mirror the weights if you have the same model replicated. All right. And finally, I think that's all I'm mentioning here. I'm just giving the already run Python code here, how it looks like. You might look at the answer, like the result of this run like this. Okay, that was it. I think I forgot to mention one thing, which was someone was mentioning, or maybe it was mentioned, with scikit-learn can also do parallel stuff. In that, I'll just say that it can, but at the same time, it cannot. Sklearn joblib is the joblib. So joblib is a sort of backend which sklearn uses to run its statistical machine models in a multi-thread way, multi-processes. So if you have like multiple cores, 20, 40 cores, some models can take benefit of that. I think random forests can do that because you can deploy a decision tree on each thread. So if you have 20 cores, you can have 20 decision trees, one at each, and do a bagging or boosting together, and then you get a final result. In that case, such a model can be used to do parallelization. Joblib helps that, and sklearn has that. By default, I think joblib uses, is it mentioned? So joblib also uses different kind of backends on how to do these parallelizations. It can also use Dask, and that's where you can mention, I'm running sklearn, use joblib with Dask, joblib Dask sklearn. Maybe you'll get something. Yeah, sklearn and joblib in the Dask examples. Here you can say, okay, backend is Dask, use joblib with sklearn to do parallelization. And that's all. It will run. A caveat here is that Dask works well if it's like one node and multiple cores. Of course, every node has multiple cores nowadays. But if you have multiple nodes, multiple cores, you might need to talk to your application expert or system admins, because then Dask will try to use, or even Ray will try to use Slurm in its own way. And that is something that cannot be just pip installed like that. Deploying on Slurm. So deploying Ray on Slurm, you might need to give it a read and how to do it. And then you'll be able to do multi-node, multi-CPU, multi-core processing on your models. That's all I think from today's session. I'll close there. All these links, keep using them, are here in the learning material. And always do my model spider to understand which versions are there. Finally, I think summary, I can close by the summary. Bjorn, or do you want to say something about the summary? Summary is just, okay, you learned pandas, seaborn, parallelization, big data, and machine learning today. Pandas Panda seaborn parallelization was quite detailed and advanced. You learn simply about series, data frames, how to do group bys, merges. Seaborn is, I regularly use Seaborn more than Matplotlib. Is just very easy. The wrapper around Matplotlib makes my life so easy. I also change themes on my charts with that. Parallelization, I stay away from that. But if you can go really like hardcore with your code and understand the parts where it can parallelized, you should do that. It's more efficient in that way. Big data, of course, someone was asking, if you have a lot of data, how do you run it on multiple cores? Well, you need to manage that big data first. So you need to understand the data types. A lot of times it happens that you just create a pandas data frame and no one even cares. Actually, the data frame has data types like object or int64, even though the actual data is only like int8. That's like lot of wastage of memory. So always take care of your data type in that case and what kind of format the data is in. There are formats which are better than some other formats for storing purposes, for processing purposes, Parakit, HDFS, and such formats are good in that case. Machine learning, you learn PyTorch, TensorFlow, sklearn, and how to load these modules in the different resources. And you learn how to do create environments and load them. So that was it, Bjorn.
Yeah, very nice summary.